And turn to the page where you have the single replacement table, and we'll see here. Okay, I'm going to work with iron and some copper 2 sulfate. All right, now good practice for the quiz today. What type of reaction is that? Single replacement. And who is going to try to replace whom here? Okay, will this take place? Yeah. Okay, so on the product side, what are we going to form? And iron can either be a 2 or a 3 charge, so I'll leave it up to you. A 2 charge what? What do you mean it's even? You mean even like 2 is even and 3 is odd?
Like, yeah, like the 2 and the 4.
Well, what's the charge on sulfate? -2. So that's why we would want to use iron +2, just to make it easy, right? So if iron has a +2 charge, then we have +2, -2. And then who's going to be kicked out? The copper. All right. So this will take place, and it's balanced. Atoms, charges, all that good stuff. All right, let me turn the lights on so you can see this. Here, I have a blue solution, kind of looks like blue Powerade. It is not blue Powerade. It is actually copper sulfate. The reason why this is a bluish color, I should hold it up. The reason why it's a bluish color is because the copper ions are blue. And here, I have an iron nail. It's a nail just from construction sites. Bought a box of them. It's pure iron. So if I take this iron and I place it in this copper sulfate, what should I see appear? Well, the iron sulfate, and if I were to ask you if that's soluble or not, you could look that up real quickly on your double replacement sheet. You would find that, yeah, that is soluble. But we should also get some solid copper. Here we have our copper sulfate solution. I have the iron nail. So if I place this nail in the copper sulfate, what should happen? Well, we have pure iron. That's what the nail is. So we have our pure nail, or our iron nail, and I'm putting it in this copper sulfate, which is, actually it's dissolved of copper ions and sulfate ions. The copper is what makes this blue.
Is the nail going to dissolve?
Is this nail going to what?
No,
no, there's no explosion. It says it right here.
It's going to turn blue.
No, it's not going to rust. What should we see on the nail? Copper. So copper metal, right? And what color is copper metal? No, it's not copper blue. It's copper colored.
It's like that's rusty.
That's not rusty.
See? I can't see that far. Copper is a rusty color.
Copper is copper colored.
It's like a rusty color. It's like a rose color. I was right.
Copper colored.
I said rusty. It's like a orange.
Nobody gets out and looks at copper anymore. Here, for the viewing audience, copper is copper colored. Rust color? Rust is reddish.
It's red brown. Orange brown.
Okay, copper colored. Good. But, and I know you may not be able to see it from that far back, but this is silvery looking. This is coppery looking. There's what? No, there are not copper ions in blue Powerade. Ugh, that would be bad. So, that's our reaction. So let's talk about the half reactions that are involved here. And when we look at this reaction, let me erase those arrows there. Okay. Let me ask you this. What is the charge? Should have scrolled that down. What is the charge on the iron all by itself? Right here, this iron. Okay, let me ask you a question. Luke, when you're by yourself, should you ever be excited? It's not a trick question.
Yes.
No.
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 He told me to say yes. He kept saying yes.
No. So when you're by yourself, you have no charge. There's no excitement going on, right? It's only when you hook up with somebody that you're allowed to get excited.
Oh, you're not that kind of excited.
No, I don't know what kind of excited you're talking about.
Oh, that is a trick question. I did not know that you meant that kind of excited, because that's excited. That's not excited.
Look. I meant like having a good time, like laughing and carrying on and joking with somebody. I'm not saying you shouldn't be laughing at yourself, right? Or joking around with yourself. So whenever something's all by itself, or even, let's put that out there, okay? Iodine, remember how it ends in INE? Let's pretend that iodine is with its twin. Shouldn't be excited when you're with your twin, right? It's got to be somebody else. No. All right, so let's come back over here. What's the sulfate's charge? -2. And copper has a +2. Okay, +2 because it's with somebody. All right. What's the charge on copper over here?
+0.
Very good. Should have no charge since it's all by itself. Okay. What's the charge on, well, we know sulfate's -2. So what's the charge on iron? +2. All right. So here's what's happening. We have, let's do these half reactions here. So we have iron that has no charge is going to iron, and I'm only going to look at just the atoms itself. Iron with a +2 charge, right? So iron has no charge, goes to a +2. Agree? Good, okay. And the other scenario is I have copper with a +2 charge going to copper with no charge. Would you agree? Good, okay. So how did iron go from no charge to a +2 charge? Did it gain or lose those negatively charged electrons? Lost, very good. And so if I'm losing electrons, am I going to put it on this side, the left side, or the right side? If I'm going to write down where the electrons go for the iron, because it lost 2 electrons, do I put it on the left side or the right side? The right side. And here's something that's kind of easy to remember. Since the electrons have a negative charge, okay? -2, what's the charge on the iron? +2, okay, so make sure you're saying plus and negative. So +2 minus 2 equals what? 0. So the charges need to be the same on both sides. So if copper has a +2 charge over here and a 0 over here, what side do I put the electrons? The left side. And how many do I put? 2. Okay. So when we look at this, we want to make sure that our electrons are equal in both half reactions. And in this case, we have 2 there and 2 there. That's awesome. And in your history of taking chemistry, how many times have you seen electrons in an overall balanced equation? 0, and you're not starting today. So what we want to do is we want to cancel out any alike terms, okay? And then we'll bring everybody else down. Now, let me ask you this. Copper ions are different than copper metal. Is that true? Yeah. I mean, if you look at it, copper ions are blue, where copper metal is rust colored. No, copper colored, okay? So they're very different. In other words, I can't see any solid copper in here because they're copper ions. But here I can see copper because it's kind of brownish copper color. All right? So they're very different. So if it has a charge, it is different. So we can't say that we can cancel out the coppers because they're not the same. So we'll bring everybody else that's down. And it doesn't matter what order you put it in, just as long as it's on the respective side. Okay. And what I just did was I wrote the half reactions for each of these, and then I wrote the total reaction. This is what we would call the net redox reaction. Here's a couple things we need to check. Make sure we have the same number of atoms on both sides. I have one iron, good. One copper, good. And then the last thing I want to do is check charges. So iron has no charge, +2, so the overall charge on the left side is +2. Add 0 plus 2 equals +2. So my number of atoms are balanced and my charges are balanced. This is my answer for my redox equation. Isn't that easy? Pretty easy, yeah. So let's do another one. Okay. Let's look at this one in your notes. Okay. Where you have lithium, and I didn't even include the non-metal in this. Okay. So we have lithium and lead +2. So let's scroll that down. So we have lithium and lead with a +2 charge. And it says that we go lithium +1 and lead all by itself, right? Okay. Let's pick a half reaction. Which one do you want to start with? Lithium or lead? And it doesn't matter. Lithium? Okay. So we'll do lithium. And what's the charge on lithium over here? 0. Good. And the lithium on this side has a +1 charge. So if you want to write the 1, that's fine. And then the other half reaction looks like this, where you have lead +2 going to lead, no charge. Okay. So let's balance the half reaction. So with the lithium, how many electrons did it gain or lose to go from no charge to a +1? 1. And what side am I putting the electron on? The right side. Again, what I want to do is I want to balance charges. So -1 + 1 equals 0, right? Okay. And then looking at the other, what do I do? I'm going to put 2 electrons over here, right? Okay. So again, I want to make sure that this half reaction is balanced. So -2 + 2 equals 0. All right. Now we've got something interesting. Do we have the same number of electrons on both sides? No. How can we do that? We multiply the top by 2 and the bottom by 1. Well, you don't need to multiply the bottom by 1. So now I have the same number of electrons, and we have to make sure our electrons are balanced out before we do anything else. So the electrons are now able to cancel. And what will my finished reaction look like? It'll be 2 Li, right? 2 lithium with no charge, plus what? Lead +2, and there's only one of those, okay? And then it'll be, again, remember your parentheses, so 2 lithiums with a +1 charge, and do include the charges. You have to include charges, because if you don't include the charges, then they're the same on both sides and they cancel out. And then lead with no charge, okay? So let's check. What's the total charge on the left side? So 2 times 0 is 0 plus 2. And then 2 times +1 plus 0 is 2. Do we have the same number of atoms on both sides? Yeah, isn't this easy? It is. It is not on our quiz today. Yep. I know, it'd be easy points, I know. Alright, let's do one more. Okay. Actually, yeah, one more of these. Let's do 2A. Okay, this isn't your homework, but let's go ahead and do 2A. Chromium +3 and zinc. Okay. Chromium, what did I say, +2? 3, thank you. 3 and zinc. And it will make chromium no charge and zinc +2. Is that right?
Yep.
Okay. All right. So let's look at the half reactions. Which one do you want to do first? Chromium? Okay. So chromium +3 going to chromium, no charge. Let's just cut to the chase. Where are the electrons going? Left side. Very good. And how many? 3. Very good, because there's no charge here. So that means we need 3 electrons. Okay? And then, so is that okay? Yep. Then looking at the zinc, how many, whoop, 2 there. So, electrons, and where are they going? The right side. And as a heads up, electrons will never be, in the 2 half reactions, electrons will never be on the same side. Okay? Somebody has to be giving away the electrons, and somebody has to be accepting the electrons. Okay? So in other words, zinc, is it giving away or taking electrons? Giving away, very good. It's losing. Therefore, the chromium can gain those electrons. Do we have the same number of electrons on both sides? No. Nope. So we need to multiply them up. So we're going to multiply the bottom by 3 and the top by 2. So the electrons are gone. And then, how would this look? 2 Cr plus 3, good, plus 3 zincs, no charge, plus 2 chromium, no charge, plus 3 zinc, plus 2. Okay. Charge on the left side? What's the charge on the left? Plus 6. So 2 times 3 plus 0 plus 6. Charge on the right? 3 times 2 plus 6. Are we balanced? Charge or atom wise? Yep. Awesome. Okay. So those are pretty easy, right?